Hello everyone. In this video we will continue to examine the harmonics of standing waves in strings with two fixed ends. So, hopefully you've had a chance to draw out the fourth and fifth harmonics and find the frequency from the diagram. Let's take a look. In the fourth harmonic, which as we remember will have 5 nodes and 4 antinodes, you can see that you can fit 2 full wavelengths in that fourth harmonic. Those 2 full wavelengths fit in L, and therefore 2 lambda is equal to L. But we're going to write it slightly differently, in part to sort of show a pattern that we're going to use a little bit later on. So we'll write that as 4 lambda over 2 is equal to L. That means that the frequency of the fourth harmonic is equal to the velocity of the wave divided by lambda, per usual. And lambda, in this case, the wavelength, is equal to 2L over 4. And therefore, the frequency of the fourth harmonic is equal to 4 times the fundamental frequency. Well, notice here that that 4 came from that fraction. So by writing this as 4 lambda over 2, we can sort of easily see what that pattern will be for the fifth harmonic. In this case, working backwards this time, we can expect, oh, well, it's probably going to be 5 times the fundamental frequency. That integer right here, that's 4, is probably going to be 5 for the fifth harmonic. And working further backwards, we can see that we might expect that 5 lambda over 2 would equal L. So let's double check. 5 lambda over 2 is otherwise known as 2.5. So we have one wavelength, a second wavelength, and half of one more for 5.5 wavelengths fitting in L. So, a couple broad patterns here. Firstly, note that each harmonic is an integer multiple of the first harmonic. And the harmonics are almost always named such because they are integer multiples of that fundamental. And so if you just march up the integers, you get sort of the higher harmonics. A single note on a guitar or violin includes both the fundamental as well as, to greater or lesser degree, other overtones, or the higher order harmonics. So a single note on a guitar includes many of these, all superimposed over one another. And the amount of each is fundamentally related to the timbre. That's the thing that makes a C on a guitar sound different from a C on a violin. The number and type of superimposed waves is this timbre. Note that if we take this mathematical relationship between the frequency, the length, and the velocity, we can summarize it in this chart here, giving us that lambda sub n for n in the integers is equal to 2L over n, and then the frequency corresponding to the harmonic, so f sub 4 for the fourth frequency, is equal to 4 times f sub 0, that fundamental. The only n which we play around a little bit with here, just for notation's sake, is we call that first harmonic f0. And then the remainder are numbered the way one would normally number these things. So the fourth harmonic is numbered f4. So f4 would be equal to 4 times f0, the fundamental.